Here's a multiple choice question. What's the value of this integral? Richard Feynman would define a function f of y to be this integral with 4 replaced with y and 3 here replaced with an integer parameter n. When n is 0, L1x to the power of 0 is simply 1. So this f sub n equals 0 as a function of y is simply the integral of x to the power of y dx. The integral is 1 over y plus 1 times x to the power of y plus 1. The lower and upper bounds are 0 and 1. We plug in 0 and 1 into this function to get the expression for this f sub n equals 0 of y. It's simply 1 over y plus 1. We now look at the first derivative of this function sub n of a function of y. So we simply take the first derivative of this integral, or the integral of this first derivative. Ln(x) to the power of n is independent of y. We take it out. X to the power of y is e to the power of y times Ln(x). So we are evaluating the first derivative of an exponential function. We have this Ln(x) here, and then multiply by this exponential function here. We clean up, we have the integral of Ln(x), now to the power of n plus 1 times this exponential function, which is equal to x to the power of y. And if you look at this carefully, it's simply f sub n plus 1 of y. We simply replace this n with n plus 1 in the function of f. So now we know f sub 1 of y is the first derivative of f sub 0 of y. Again, f sub n equals 1 of y is the first derivative of f sub n equals 0 of y. So we plug in f n equals 0 of y, which is 1 over y plus 1. It comes from this derivation over here at the beginning of this document. Again, this is pretty simple integral calculus. We plug it in, we take its first derivative, we get negative y plus 1 to the power of negative 2. And then we have f sub n equals 2 of y. We take the first derivative of this, we get this. F sub n equals 3 of y, we take the first derivative of this, and then we get negative 6 times y plus 1 to the power of negative 4. Now we can evaluate the original integral. Over here, n equals 3, y equals 4. So we are looking at f sub n equals 3 of y equals 4. We plug in y equals 4 here. We have negative 6 times 5 to the power of negative 4, which is negative 6 over 625. It's approximately negative 0.01.